Okay, today I'm gonna do something a little bit different. Gonna make a lamp, and what you see on the screen here is pulled this socket on the left out of an old lava lamp, and also pulled the power cord out, and then this is just a an LED light bulb. It's standard size base. Um, so none of this is in SolidWorks. Gonna have to add it in to make models of it, and then once I've done that, I'm gonna make a lamp around that, and we'll see if this turns into multiple videos or what. But let's get started. Let's go make a new part, and before I even do anything, I'm gonna save it. I already made a folder. Give it a really easy generic name, and got my digital calipers. Obviously, it's off screen, so yeah, I'm not sure. This might be sort of a boring video in some ways because you won't see half of it because I don't have a good webcam. But it's obviously round, and it's 35 millimeter diameter on the outside, and on the inside, how big is it there? It's 28.75. All right, and gonna just extrude this. I think we go the other way. And how high? 38.6. And I'm going to put a cap on the end of that. Offset from the surface. Doing this just because that's how calipers work. It's easier to just measure the depth of it. That's 26.4 deep. Okay. I don't have to get super detailed. I mean, I'm not going to bother putting the threads in there and all that. And see, down at the bottom, there, it's hard to see there, but yeah, there's two screw terminals, and then there's a bracket, this thing here, coming off the bottom. So, looking at that, I don't even know if I need to bother doing the screw holes or the screw terminals because they're kind of inset. Suppose I probably should, just so I have markers for where the wires go. So I'll go ahead and do that. And they are, how big? 7.5. And they're both the same size. And how are they arranged? Really hard to say. No, they're so oddly arranged, I'm not even going to bother with them because honestly, I don't need to model them anyway. If I was going to use this for other things in the future, I'd probably do that, but yeah, there's really no point in modeling that because I don't need it for this project and I only have one of these, so whatever. So just going to draw the basic shape of the bracket that's coming out of the bottom of it. It's used to actually mount it. And let's see, I do not have an angle measuring gauge that's going to fit this. It's kind of inset and a little bit, yeah. Sometimes the hardest part of designing something is just measuring it. So how thick is this? 3.32. And how thick is the top? 0.57. It's parallel, and so it's going to be parallel with that. Okay, and how to model this exactly. Let's try, we'll convert this just so we've got an edge to work with. And just going to make them for construction, perpendicular equal, so those are defined anyway. And that way I can dimension to that. And I can actually measure there approximately enough anyway on the physical one. Okay, and the best way to do this. Okay, so what I'm going to do, take a quick note. So this section is basically round, but then it's got a tab that sticks out a little bit more. So I'm going to start by measuring the round part, which is about 16.83 in diameter. And then this, the total top with the tab is 18.1. So go ahead and make this 18.1 and make that parallel also as long as I'm here. And then just make it, I'm not even gonna use this for the model or the geometry. I'm just gonna use it for construction. So I want to go from the center here to the center there, and make that for construction as well. Perpendicular, and this is just the round part, which is 16.83. Okay, and then how far up does this come? .23. Okay, so everything turned black. That means it's fully defined. So I'm going to do an extrude boss. And see, the most narrow part of this is 8.6 millimeters. It's going to be using a mid plane. That way it goes equally in both directions. And okay. I'm going to go up here and make a circle. And I can show this sketch so I can use what I had here. So actually I'm just going to convert that whole thing and make it for construction. And I can use coincident and coincident and coincident. And so that's the overall outside bit of it. And I can just do an extrude boss up to here. Okay. That's pretty much the shape. I'm going to trim. It's actually rounded at the end here, so I can just convert this whole face and make this coordinal, and then I'm going to just start trimming and trimming and get rid of that and make that coordinal again. And if I do this right now, I think SolidWorks is going to freak out because it's zero thickness right there. So what I'm going to do is I'm going to make this part for construction. Just extend out a little bit. And make make these all parallel and equal. And then when I do my extrude cut, it actually allows me to. We'll just go up to the surface. All right. And then on this surface, there's another raised section that's got threads. So that's centered. And how big is it? It is 9.71. And it's not actually completely round. It's flat on each side, which I could just make round hole, but I might want to actually use that. So I'm just going to draw this in and make it for construction. Basically, I just want to take down my measurements at the moment, and then I'll worry about what I actually want to make useful lines out of. So it's 0.44 wide there. So basically, if we take the trim tool, trim that, and put those back in. And then there's also a hole through the center of it. And then it's 6.4. And then we just have to see how tall it is. .66. Okay, so that's what that is. That hole also continues through, so I'll go ahead and do that too. Okay, and I can hide this sketch. Okay, so that is the basic enough shape. It's not photorealistic, or it's missing a lot of features, but this is all the features that I actually need for this. So I'm happy enough with that. In fact, I'm going to go ahead and save, just because it's a good idea to save frequently. I'm going to include the light bulb right in here because, well, frankly, that saves me the trouble of modeling the threads and figuring out how deep the light bulb is supposed to go into this particular socket and all that stuff. So, if I draw on this plane, which I modeled this all centered around the origin, so that makes it easy. I don't have to make extra planes for this. I can just kind of draw out the shape of the light bulb. So I'm going to start with just the center of, like, kind of a center line of the light bulb, and go over, up, out a little bit, and let's see. Then it looks, just from what I can see, looks kind of like that, and so it curves out and then it curves back in. So that's very rough, but that's what I'm looking for. I'm going to put in a couple extra lines for construction right away. So this one's going to be actually horizontal. Yep. Make this horizontal as well. Make this a vertical construction line. Make these equal because it doesn't really matter what they are. I can just pick a random line, make them equal to it. Not always the best practice, but I know that that line's going to stay there because I'm not really going to mess with this too much. So looking at the light bulb, this is basically tangent with vertical. And I know this is going to be tangent up there because I'm only drawing half the light bulb, but otherwise it would continue around. And these are also tangent. Okay. So this part here will actually be inside the socket. So it doesn't need to be super accurate. In fact, I'm just going to make it match what the socket is. So I'm going to use an intersection curve real quick. That gives me those, which make them for construction. Then I can do that, and let's put this on the origin, and put this way down in there. Oh, Control Z. Doesn't want to be way down in there. But if we manually stretch it down there, then it'll be perfectly fine with it. Okay. So this is at an angle. I don't need to be super accurate with this because it's not like I'm making one of these. It just needs to not bump into anything when I put it together. And I'm going to say it's about a 60-degree angle. Should be or 30 degrees in this direction. Looks about right. Okay. And then I want to see how far this is from center. So just go like that. Make for construction horizontal. And I'm just going to make sure it's centered right on there so I can do make these both for construction perpendicular equal and make this tangent. That way that's centered right on the farthest point. And then I just need to measure the outside of the bulb, outside diameter, which my caliper just barely reaches. It is 60 millimeters, so half of that is 30. And that clearly needs to be vertical. Okay. And let's see. We just need to add constraints until this thing is all locked down. This angle starts like right as it comes out. So that's easy enough. And measure the top of that angle is 7.4-ish. Okay. And then we should probably have the entire height of the bulb. Which I'll take it out of the socket for that. And it's about 86 1/4. And then that's fully modeled. So I select the center line, go to revolve boss base, and I'm go ahead not merge this. I have it as two pieces in case I'm going to separate them later. Maybe I'll pick a different bulb, but I think I'll go with this bulb. So yeah, that's basically what I'm going to be putting in. But in addition, there's, well, let me go ahead and save. In addition to that, down here, this is actually threaded, but I didn't model it that way because there's really no point. I just need to know how big of a hole to make for it to go through. But I am going to model up the nut, and that way I can at least remember to deal with that. So I can just made a polygon 6-sided. And grab the inside, the circle, and that will be the distance of the flats, which is easy to measure. 13.81. And we'll center it. And just say horizontal, good enough. And I'm actually going to start it from here. But I'm going to go the other way. And it is 3 thick. And I don't want to merge this. And okay. Then I'm going to go back in the sketch because I noticed that I only did the outside. I need the hole in the nut too. So again, not going to bother making it threaded or anything, just good enough for the modeling. That's all that really matters on this. There's also a washer, but it's thin, and I don't even know if I'll end up using that. So I'm happy enough with that. I'm going to rename it. Okay, so got our inputs. Might still need to do a measurement or two on the cord for a hole to slide it through later, but that's good enough for the time being. So now I have to figure out how I want to use this. For starters, I'm going to make a new part, and I'm going to save it right away. Call it, I like to always go ahead and start putting version numbers when it might be something that gets changed a few times. And I'm going to insert part. This is kind of like an assembly the way this works, but not exactly. But it references that other part, unless if I right click here, click external references, I can either lock it or break it, or I could just, yeah, there we go. Yeah, but for now I'm just gonna leave it. I might decide I need to add another feature or change something. So I'm gonna go ahead and also add some stuff, because this is going to be made out of wood primarily, with maybe some acrylic accents just to make things interesting. So I'm going to do, instead of material thick, I'm going to do wood thick, because I'm going to have some acrylic as well. And I know wood's about 4.5. And kerf is about 12 if I want it to be nice and tight. Do the acrylic thick too. That is about 2.8-ish. And this is all just experimental stuff. I do a cut, and I figure out what the kerf is, and then I can just use that. So these kerfs aren't really from a lookup table or anything, or calculated. It's just do a cut, a test cut, a little square or something, and measure how big or small it is compared to what I wanted it to be. So just by the way, how thick is, or how much distance? We don't have a whole lot of distance there, so that might be a little tricky. Let's see, 6.4. So I might end up putting, I like to work metric, but 6.4 is just a little bit more than a 1/4 inch, I believe. Oh. So yeah, so it's just a little bit over a 1/4 inch. So if this nut doesn't go on because my material is too thick, that's not a big deal, because I can just run a 1/4 20 screw through there with this and use that instead. So let's start modeling here. Do a sketch in this plane, and I'm gonna make it. Basically, at this point, I have to start deciding. Do I want it to be square? Do I want it to be circular? Circular gets a little bit hairy sometimes. And then if I want it to be flat sides but not square, especially with laser cutting, which is going to be laser cut, it gets a little bit iffy. With the fingers, they don't. The fingers are always cut at 90 degrees because it's laser cut. That's the only way you can cut things on a laser. So that they don't fit very well if you've got angles that aren't 90 degrees. But at the same time, I don't want this to be just a boring square. So, yeah, I'm going to do, you know what the heck. Let's make it a lucky lamp. And horizontal. Actually, I take that back. 7 is not a great number for divisibility. 9 is a good number for divisibility. And just pick a random one, make it horizontal, just so that it can lock down later. And how much clearance do I want? By the way, I can just grab the edge here and convert. That's my minimum, so 60 millimeters. If everything, that's as far as I can come in before I hit the bulb, basically. But I don't want to be touching the bulb, even though it's an LED and it's cool, or not hot to the touch, that is. I'd like to have it at least a little bit of space, say 50 millimeters, about 2 inch if you're in the States. And so how big across on the outside does that make it? It's 160 millimeters, which that's a little over 6¼ inches. So that's not it's not exactly a huge lamp, but I think it'll look respectable. But why not? Let's make it a little bit bigger. A lot bigger. Why not? 260, which that's a little bit over 10 inches if you prefer. And yeah, I think that should come out well. I'm gonna do grab these 4 parts, do an intersection curve, so I get that shape for the center, and can add things into the sides later, but we'll just go ahead and extrude this for now. Equals wood thick, and I don't want to merge it, and it's not happy. Even though it generated the syntax of that equation, it's still not happy. Why is that? Because sometimes SolidWorks just does that. So I'm going to save. Okay. And I'm going to close SolidWorks. And then I'm going to open SolidWorks. And basically hope that that error didn't mess up my part. So that happens sometimes. Come on, SolidWorks, you can do it. Let's see if it lets me do it now. Syntax is incorrect, which it's generating the syntax for me. And it's perfectly fine. It's just giving me an error for no good reason. Hooray. Try. Sometimes removing the external references fixes that. Do a few control Qs, save, extrude, equals, and then it's happy. Where'd the error come from? I have no idea, but it's gone, and that makes me happy. Okay, so this is not merged. Wood thickness, it's going down, so it's not interfering with the metal part. So I pretty much buried the nut, and the nut, as I modeled it as far off as it could. So basically that nut's going to be unusable. I'll just have to use a 1/4" screw with a washer to hold it. That's fine. And let's see. We want the bulb, ideally, I think, to be about midway up the lamp. That seems logical anyway. So how do we make the center of the bulb midway up the lamp? What we can do is we can use planes. We want this to be parallel and tangent. And then make another plane that's also parallel and it's also tangent, but it's tangent the other way. And then use the two planes together to make a midplane. So that's halfway up the bulb, or halfway right up at the center of the bulb. And then I'm just going to go ahead and mirror this body. And I want to convert all inner loops, which there's only one, but it's easier than selecting it. And up to surface there, only with that. Okay, and I can change this to mid-height plane and then hide it. Okay. Now right now, obviously, if we make this all wood and just encase it, this is not a lamp, this is just a bulb inside of a box, but we'll take care of that later. So, we have 9 sides, and we need to actually make those sides. And we've got lots of options, and we can kind of say we want to be this style or that, but let's see. This is the first side, I believe. No. What side is... That's the first side. Might as well start with the side that's nice and straight. Saves a little bit of trouble of using these other ones. So if we go corner to corner, then it's going to interfere with the one on the next side. So we can do that if we use fingers to lock them together. Which I probably will use fingers, but there's another little issue with that, is that if I do it right at the edge, then there's nothing holding it in other than friction and maybe some glue. And I prefer to have a little bit of mechanical advantage when I can get it for free. So I'm going to do that. I'm going to make this wood thick. Yes, I'm going to make that wood thick. I'll put the acrylic in as inserts into the sides. And I'm going to make a new variable here. I'm going to call it safe distance. And for now, I'm going to call it 4 millimeters. Maybe change that later, but for now that works. Okay, so then this piece that I'm designing, that'll go up to the top. That's inset by the distance that I think is safe. Go center to center. Make this for construction and then perpendicular. Okay. And then, well, I end up having to make one of these anyway. So make a corner rectangle. Gonna go center to center. Make that as equal. Make these equal. Make these equal. These parallel. And make this perpendicular. And all of this needs to be for construction. And what I'm going to do with that is I'm going to take this point and merge them. So that will set the width for this piece, which ends up being 91.72, which you know, I don't need to really worry about how big it actually is because SolidWorks calculated it for me. As long as I can cut it, it's good size. So I'm going to go up to here, and I'm not going to merge that. Okay, so that's one side, and obviously you'll need 9 other sides, but I'm just going to make this one side how I want all the sides to be, and then we can worry about making the other sides. I'm going to hide these, and I'm going to make some fingers on this. And down here as well. I'm going to get rid of this vertical. That way I can just go collinear, equal, and make these equal as well. And let's see. Don't have to make this too parametric. Let's see. This needs to be wood thick to match with the top. And I'm just going to make a line right there for construction. And I'm going to make this wood thick as well, just equal. That way it'll be a nice square. I'm going to select the chain and do a linear pattern. I'm just going to grab this edge so it follows it. It was kind of already going, it was it was almost certainly exactly on that direction, but now I know for certain that it is, as opposed to just assuming. And let's see, 4.5 times 2 is about 9. So this isn't quite as precise and parametric and all that and adjustable as my last design, because this is more artsy, I guess you could say. Yeah. Hey, 9. This is the 9 lamp now, I guess. Okay. And there, and we can do one more there. This is for construction, and then equal. And then these two, also for construction, also equal. And okay, so that's a nice pattern up there. Forgot to grab this one when I did that pattern. So what I do is I grab one of the patterned entities, right click, edit linear pattern, go down to entities to pattern, and I can grab these 4 lines as well. So top and bottom done, fully defined. I'm going to do an extruded boss up to the other side, and tell it to only merge with that. Okay, so that's set. Now, if I made this just like it was, or with 9 of these around, obviously, these would tend to kind of bow and shift and not really fit together really well over time. So what I'm going to do is I'm going to bring back the visibility of that sketch. So this is the overlap into here. So I'm going to draw on this surface. Just going to quickly draw a rectangle. Oh, I want to grab that edge. Come on, there we go. And I'm going to grab that there and do a coincident. And then I will go up to the top, do a coincident. And just for my own sanity, I'm going to go down here just so I can see this on both sides nice and easy. Oh, did I grab the right thing? No, I did not grab the right thing. Equals. Okay. So, hide this again. So inside of here, that's where fingers are going to be. Basically, on this side, I want to cut out to match on this side when it's not a cutout. I'm going to go ahead and make these all for construction right away. So let's say I go, I can't do the the same method I did over here. I need to actually have this, this part needs to be a little bit more parametric. So how do I do that? How I do that, first of all, is I grab this and just call it a driven dimension, and I can give it a name. And that name, let's say, is invert. Good enough. And I'm going to exit the sketch and rename it to scale 1, whatever. If I was inside of a corporation doing this, I'm sure I'd be following some very much better procedures, but hey, I'm not, so hooray. Okay. So I have to make a second sketch because if I reference that within that same sketch and do a rebuild, it's going to freak out on me and refuse to do anything. But if I reference that from another sketch, it's fine. So, whatever. So I'm gonna, kind of like I did the other day, just might not even need all these, but hey, I'll just draw in a bunch of them real quick. I do parallel, equal, and coincident. So they're all like that. And yeah, 25 works, whatever. And then I'm going to do a bunch of these lines. Just to do the math, kind of like we did on the cube. Oh, didn't want to grab the dimension. I want parallel, perpendicular. Okay, so what's this first one? This first one is going to be equal to that divided by wood thickness. Okay, so that's, if we made them all perfectly square, that's how many we'd have room for. So let's do another one. And this is going to be equal to this minus 1 divided by 2. Okay. And we're going to do a third one. It's going to be equal to int, which is just round down to the nearest integer of that. Okay. So that's going to be, you know what? That is not how I want to do it, because that would be perfect if we wanted to always have like a solid and a solid here, and then on the bottom, on the other side, it would be starting with not a solid and a not a solid, but I want this to start with a solid on top and a non-solid here, and then this will be a non-solid on top and a solid on the bottom there. So need to change this around a little bit. I'm going to get rid of this minus 1. And it ends up being the same number here, but it would be a little bit different if our dimensions were a little bit different, which once I type in the actual wood thickness, once I measure it, it probably will be different. So I can give this a name, I believe. Doesn't want me to give it a name. There, we can give it a name there. And what can I call this? Half finger count. Okay. Okay. And I'm gonna get out of here, rename this to scale 2. And make another new sketch. And this one, I've got that, and I've got that, thereabouts, coincident, coincident, and I want to be coincident with those. I want to be coincident with here. And I want these two to be equal. Okay. So now, I'm going to make a formula. This is our total height. So I'm going to go equals to this, divided by this plus this. Basically times 2, but I can just do addition because it's only 2. Either way works. Okay. And I'm going to select this chain, hold down Control, select this chain, do a linear pattern, and I'm going to go this direction and call it 101. And then I want it to be this many. Which is 25 right now, but again, we change our wood thickness or something, that's going to change. So we can do a coincident there. So if we go down to the bottom, it should line up about perfectly. Let's see, if we select both of them, normal distance 0. Okay. So then we can do features, extruded cut, through all, and then just on that part. And let's hide these 2 sketches. And hide everything, then show everything. And I want to make an axis just for the very center. We'll name it center. And I'm going to drop it way down, way up at the front. And then I want circular pattern. I want 9. And I want to select bodies and that. And okay, that looks good to me. And okay. Okay, so we've got the sides, we've got the top, we've got the bottom, at least the bottom of the light part. We still need some kind of a base or feet or something like that. But we've got a good start. So what do I need to do next? Well, the first thing I'd want to do, after just double checking that these don't interfere with each other, which they might. So let's check if those interfere with each other. Go to evaluate interference detection. And let's see. I want to exclude bodies, which would be this and that. And then let's calculate. And no interferences. So these are super tight. I mean, they're line on line, but they're not interfering, which is good. Now, let's see, which one was our first one? This one was the first one. So I'm going to make a copy of that. And let's see, this one, I want to hide the original, keep the copy, roll this forward, and I'm just going to copy all of them again. Actually, yeah, I'm going to copy them all again. Just think about for a second about using a sketch to do this, but if I used a sketch to do what I'm about to do, then any changes to the number of fingers would mess it all up. This will be a lot more resilient. So I'm going to do a combine, subtract. And I'm just going to start going around, selecting them, since I have two on top of each other on all these faces, some of these like don't look like they're necessarily highlighted, but you can still see that they are. Or it's just not the one that it's wanting to show that's highlighted. I'm going to do the subtract on that. And I'm going to do the same thing on the bottom one. This time they'll all look highlighted because I'm basically getting rid of everything that's visible. Okay. Alright, it's good. This one, the reason I'm just keeping this one is because I still haven't put, the assembly chamfers or anything like that on there. So why bother actually patterning it before then? Well, because I wanted to make these cuts. And I don't want the chamfers to be on there when I'm making the cuts, because then those will be, like, we'll still have a piece right there, which it wouldn't be ideal. So I'm going to save again, because I don't save enough. I'm going to hide the center, because it bothers me, because I'm weird like that. So how are we going to hold this on? I already figured out I'm going to use a quarter 20 bolt, and I can't really put it in from the top. I'm going to have to put it in through the bottom, and I normally do everything in metric, so I don't have a whole lot of hardware available that's English stuff. But I do have some. Quarter 20. So I just have a kind of a library of parts that I made for myself over the years. This is one of the ones that is very old. Oh my, this is probably 2 or 3 years old that I was still using this way of modeling. So let's see. How much space do we actually have? So from there to there, it's 25. So maybe that'll probably work. Yeah, probably, maybe. So this is a huge file. I stopped modeling this way because it ended up with files that are too big. So instead of putting this in there into the file we're working on, I'm just going to insert this body into new part. And this was 19 millimeter. Yeah, good enough. I'm gonna do external references and break the link. And click save, and click save all. And this is why I stopped modeling in the old way. So I'm gonna let this run for who knows how long. And then I'll pick up the recording once that's done, because I don't think you want to sit here waiting for it. Okay, and I'm back. So got a screw. Let's drop that there. And I also went ahead and just got a lock nut. Just download it from McMaster Car and yank the threads out of it. And I don't like to put actual model threads and stuff because it just wastes so much computing power. I'm going to do a move copy bodies and go there to there. And okay, and where'd it go? It went up there. So there to there. Actually, I'm going to cancel that because I want some kind of a washer. Yeah. So I need a washer that is at least, what, 9.71. So about 3/8 inch inside diameter. And I'll probably just pull something out of my parts bin, but just to get a rough idea of what this should be. OD is all over the place. Looks like 875 to 1 is the most common. Either 875 or 1. So black oxide usually is the most common size because they usually only have 1. So yeah, I'll call it 0.875. And I'll just draw it in. And if you get a dimension in inches, you work in metric, just type in IN. There you go. Converts it for you. And how big is that on the inside? 0.406. I could do this as a separate part, but why bother? It's so simple. Oh, we want 406 inches. Okay, and we'll just make that concentric. And how thick is it? So I'm going to figure on the high side, which is 0.06 inches. And I don't want to merge that. Okay. So let's hide this for a second. And we don't need that. We're not going to be using that. So I just want to make sure everything looks like it will fit. Okay. And yeah, I think that'll work. So now I can do the move copy body on this. Do a concentric and then a coincident. And yeah, doesn't matter how it's rotated. Do the same thing for this. This one doesn't really need a washer. I might end up putting a lock washer when I actually assemble it, but for modeling purposes, it doesn't make really any difference here. And looks like that went upside down, so we reverse it. And it's inside the bulb, so we get out of there, hide the bulb, and we can edit this again. So we've got our concentric, but now we need our coincident. And okay. And let's see, does that have an issue? Just to make sure this rotates, I'm going to do a parallel that. So yeah, the point doesn't quite touch. Goes through, that actually works out pretty well. That hole through the center of this bracket here, or this bracket, I think that's intended for wires, but the wires I have are too thick for it anyway, so might as well use it for mounting instead. Okay, so that's attached. Still needs some kind of feet or base or something like that. And I'm not exactly sure what I'd want to do for that, but I do know I have 9 sides, which is divisible by 3. And 3 is a good number of feet to have on something, because even if your table's a little bit wonky, or you're putting it on a carpet or whatever, it won't rattle around. So I just need to figure out exactly how I want those 3 to be laid out. And I think I've got a plane that's just right. Okay, so that's like right in the middle of this. So if I model one up here, then I can do a circular pattern around. So I'm going to do a sketch on this plane. And let's see. Start with a very general footy shape, if that's a word. Okay. And let's see. Let's use this line as a coincident. That'll put it right on this face. And do I want it to be straight up and down, or do I want it to be angled in and out? I don't want it to be angled like that, even if this was moved in more. I do kind of like the look of that. This is more of a just how do I want it to look kind of deal. Let's see if we hide that. Okay. We don't want it to be quite touching that, or you know what, I almost want it to be touching that, not quite. I want to leave a little bit of safe room. In fact, just in case I happen to find a washer that's on the high side, like so, these go up to about 1 inch. Yeah, I don't know what I'm going to find in my parts bin, so I'm just going to make another line that's parallel and centered. So use perpendicular, that way it's center, perpendicular, so then this line is centered as well. And yeah, that might be as big as 1 1/8 inches, which would be what, 28 millimeters? Call it 30. That works for me. And then this is all going to be for construction, so do a perpendicular and an equal, and then I can go from there to there, coincident. And let's make these all for construction now. Okay, so that's going to be the inside of this. And come to think of it, I'm going to want this to come up, and it's going to be vertical. And then I want it to come out. Do I want it to be straight? I don't think I do want it to be straight. I think I want it to be a little bit more creative than that. So what if it was something like that? And let's see. Do a parallel equal and for construction, just so I can go tangent to this. That way it's tangent to horizontal. And how high do I want this wall to be? Well, I would like it to be maybe 1 millimeter beyond the screw. So I want it to always be covered in screw, even if I end up with a wash that's maybe a little bit thicker. Okay. Now, what about the feet? Ideally, I want them to be at least at the outside. It could always go a little bit more outside, but then I'm taking up extra table space. So I'm going to have it right on the outside. So I can select this edge and this point, and coincident. Okay. So we've got a good basic design. It's still not fully defined, but it's getting there. How much height do we want to add? Again, this is just kind of opinion, personal desire, whatever you want to call it. I'm going to call it 50 millimeters. Actually, no, I'm not. Because I don't want this coming to a point. I want this to be rounded. So I'm just going to put in an arc and do a tangent and then another tangent. And how big of a radius for a foot do I want? I think, let's see, 3 millimeter radius, 6 millimeter diameter. Yeah, let's go for a 10 millimeter diameter. Okay, so then if I go, I'm just going to go ahead and convert this so that I've got it, make it for construction. Go like this, and then like that. I don't want it to be on the center, I just want it to be coincident. Go tangent, and for construction perpendicular, and then perpendicular as well. Okay, so now this will be the bottom of it, and I want that to be 50. Okay, so we're slowly coming together. Now, this coincident I made earlier is pointless because I want it to be tangent here. And let's see. I could make this curved as well, but I'm actually okay with that being a hard edge there. Maybe. Probably not. Decisions, you know. Okay, how about we make this curved as well? Make this tangent there. And I'm going to make another construction line that is perpendicular and equal because it doesn't matter how long it is because we're just using it to get a tangent constraint. And then I want this to be inset by the safe distance from before. So let's just convert that. Some of these might disappear with wood thickness, but the center one should remain. And it did not like that one bit. Okay. Okay, so I can go in to a certain extent, but I can't go. That's interesting. So I'm going to Control Z that. Let's try it from the other end. Okay. That's interesting. Oh, you know what? I don't want this to be tangent with the line. I want it to be tangent with this. Can I get away with it now? Probably not. What if I get rid of this entirely? And I'm also going to trim this back. Now can I get away with it? Now I can get away with basically whatever I want. Okay. So from there to there is safe distance. There we go. And it's just going to go over to here now. And let's see. Make these equal because they don't really matter. Okay. So I've got a basic foot design. I think that can work. I'm going to go ahead and just make that extrusion as it is. And I don't want to merge it, and I want it to be mid-plane. Now, I need to attach that somehow. And what I'm thinking is maybe I'll use some slots so I can stick it in there with it being a little bit farther outward and then just kind of push it in. Either that or, you know what might be even better if it was the other way. If I put it in before I put this screw or the screw in the washer in, if I drop it in there and I drop the other two in there and I slide them outwards, and then I have something in the middle that kind of locks them in place, which could just be a laser cut piece. Yeah, I think that could work very well, actually. Especially since then I don't even need the washer, I don't think. Alright. Let's change this. Let's go back a little bit. So, let's get rid of these dimensions. Since I'm not going to buy this washer, I am going to laser cut this so I can make it exactly the size that I want it to be. And let's see, let's hide that. Alright. And just how much do we want? Let's say, I don't know, 10 millimeters. Nice round number. Okay. And how thick is it? Well, it's made out of wood, so it's wood thick. Alright, there's a screw. Might end up needing a slightly longer screw, but that's okay. They make longer screws. And then this sketch. Alright. And we can get rid of this whole mess right here. Or, no, not that mess. We can get rid of this mess. Yes, we don't want that. We don't want that. We don't want that. We want this to be coincident with that. And we want this to be perpendicular. And this just parallel equal. And we're fully defined again. So now we've got that wood thing that locks in. Alright. I think we've got the start of a winner here. Hide, hide, save again before I forget again. So now I need some tabs here. Don't need a whole bunch of them, but basically I want to go like that, 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 and that. And maybe only 2 or 3 of those. Go parallel, go parallel, and then perpendicular. Okay. And this is going to be wood thick. And I'm going to make this safe distance times 1.5 just to make it a little bit stronger, since this is kind of going to be under a lot more load. Right. So this whole thing has to slide in through the hole. So I'm going to make these about equal. I'm going to make this wood thick times 2 here. And just call that equal. 9 millimeters is plenty there. And let's, before I start patterning this, let's see, maybe put a chamfer there. Don't need one there, but it might look nice. Don't need one there, but it might look nice. So, actually, let's do a fillet. So I draw in the fillet. That way it doesn't mess with my original lines, which I'll just end up converting those to construction lines. And I could probably use the fillet tool, but whatever. I can also draw them, so I'm going to draw them. That's my priority. And equals, and what's my radius? Say 2. Doesn't really matter. Yeah, 1.5. It's 3 millimeter diameter. Good enough. And I might as well make this about the same. So let's see, there, there, and there, and there. Hide these real quick, or make them for construction so I can grab these. Maybe equal, and it's gonna go like that, so that those can be equal as well. Okay, make all these for construction right now. And I want to keep this, 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 and these as well. Draw in the remaining lines. Okay, just for a test, I'm going to do extrude boss. I'm not actually going to do it, just want to make sure that it's a nice closed profile before I start patterning it. And just for giggles real quick, that's 18 millimeters across. So if I go along this direction, the other way, go in that direction, let's see, 18 times 2, 3 of them, 3 fit, okay. And I'm going to do a coincident, and let's see, how did I have that? Yeah, that's already inset by safe distance. And really this can go all the way to touching, basically. So let's just convert this face and then hide this again. Again, that's like the middle one, so even if we change wood size, it won't really affect it that much. And just say 1 millimeter, that's plenty of clearance room, so it's not touching. So this shoves in, slides out, repeat twice more, then put the washer in, and it locks it in place. And I'm pretty happy with that. So, extrude boss, up to surface, over there. We only want to merge with this part. Okay. And good. I think. Might need to still adjust that because we have to put it through the thing. So we can make a cutout right there. That's not a problem. Make a cutout right there. That's not a problem. Can't make a cutout right there. That's a problem. So we're gonna have to modify that again. And coincident. Good. We can bring this in. And let's see. Let's make a line that's equal to this. And make it for construction real quick. Make another line. And then drop down. It's going to be for construction and perpendicular. And make those parallel. And then equals safe distance times 1.5. And okay, so these are 18, and the distance between them is a little bit over 18. Okay, that works for me. Let's see how it looks. All right, let's gonna make basically just make the cuts so, like this. Could probably pattern these, but why bother? Remove the verticals. SolidWorks isn't going to freak out too much if I leave them, but during a rebuild, sometimes having unnecessary additional constraints like that will freak it out. So better to just remove them when you remember to. That way you don't have to try to figure out why SolidWorks is freaking out later. So I want it to be this distance, but I also want to have a little bit of wiggle room, so I'm not trying to force them through. Parallel. These are also for construction, of course. This parallel. I don't need a whole lot extra, just half a millimeter is plenty. So then I'm going to draw another line on top for the total length. And for construction equal. Okay. So I'm going to do an extrude boss. You'll see why in a second. Up to here. And I do not want to merge those. And so I've got these three parts plus that. So I want to do a circular pattern of 3. I want it to be around the center. And it forgot the ones that I selected. Fine, whatever. Okay, good deal. And then I'm just going to hide these for now, which leaves those. And I want my plate back. Okay, so I'm going to do a combine subtract. Select the plate. Then I'm going to select all these. So now I've got my slots, and I've got my feet, and I've got the washer that locks them in place. And that doesn't, I'm not sure I like that look. I want to modify that just a little bit. Delete that, and I want it to be, well, let me get away with that. It will, okay. Yeah. That works, I think. Let's go back, just get an idea of the overall look of this thing so far. So, undo this, but it's just for just to get an idea of what I'm looking at. So I got a little lamp. It's got 3 legs. It's going to have a power cord coming in the bottom somewhere. Or I suppose it'll come in the back, but might as well come in the bottom. Speaking of which, I might as well figure out how big of a hole I need for that power cord real quick. So pull up the calipers. Still got the cord here. Let's see. Let's roll this back. So even though all the sides are kind of the same, for now I'm treating this as the front. And since I can't run it through the center, the power cord that is, I'll start with a rectangle. See how wide it is. And how thick it is. Okay. And it's, of course, it's rounded edges, but it's not like a slot kind of rounded. It's like it's rounded and flat and rounded and flat. It's kind of an odd shape to this power cord, but I've got it already. It's plenty powerful enough for the job, so I am happy with dealing with that. So all I need to do is, first of all, I'm going to make these for construction. And then I'm going to draw in some new lines right on top of them. Actually, you know what? I'm not going to do that. I'm going to do 3-point arc. And just do that 4 times. it's hard to measure the actual dimensions of this chord, but I'll get close anyway. And tangent, tangent. Now, with most power chords, I just use this straight slot feature, but like I said, it's kind of got straight edges on the sides, which is unusual for a power chord, but whatever. And I guess it's about just for rounding everything. For construction equals, and that tells me some of the ones that weren't made tangent yet. Just for giggles, I'm going to fix this real quick. Okay, that tells me that that's all constrained, except that I can move it in space, but this as a shape is constrained. Add these lines in. Okay, and I'm going to put a point right in the center there, and then grab the plane. So it's, yep, I can constrain right to the plane just like it was a line. And that way I don't have to actually draw on a line. Take this bottom line, I'm going to offset it. I don't want chain, just the line. And I want to go that way. And I can't put in a formula here, so I'll just accept what it gives me. And I can double click this and put in the formula there. And I want this to be for construction and tangent. And there we go. That's all locked down. And just goes through there. Okay. So now power chord goes in there, goes up to there, point, and the power switch is on the cord back here somewhere. Or more likely I'll put a smart bulb in this, and then I can just say, okay, large company that I don't want to say because it'll activate my speaker right now, turn on the light, and then they'll turn on the light. Okay, so next steps, we need to chamfer these and these to make them easier to assemble. And I'm going to draw these in and use formulas, because if I just do a manual chamfer and it changes the number of fingers, that screws everything all up. So I'm just going to do the leftmost and the top. So, and then down here as well. Close. And one more set over here. Okay, come on. And that means an new variable. Okay. And yeah, I made this so that it's always 9, so that's easy enough. my direction, and I want it to be 9 of them. Okay, do a coincident to there, and it's fully defined again. Then this is going to need an actual formula. So linear, and I want to go in this direction, the other version of that direction, call it 101 of them, and this was that. So I've got, I want to try to drag that dimension out, because if I try to double click it, it might just double click something else, and then sometimes SolidWorks kind of freaks out about that. Even dragging it out there, sometimes SolidWorks freaks out a little bit. Yep. Didn't do anything at all, just wasted some time. Great. Thanks, SolidWorks. Alright, do a coincident there, and I'm fully defined. Good deal. Let's do a cut through all only on this part. And then, yeah, all my edges are chamfered. Okay, so now I could put this all around. Question is, how does light get out if I do that? I need to make some kind of cuts here, maybe some cuts here, maybe even some cuts in the bottom, so that light can get out. And originally when I started this, I was thinking I'd use some form of some acrylic inset in there. And I'm still not sure if I'm going to do that. I could, and I suppose I could just make cuts that are just open without the acrylic. Or, in theory, I could like use something like paper also. Just glue some paper to the inside, make cuts, glue paper to the inside. But saying that, I'm looking at this and going, what happens when I need to change the bulb? So I'm not going to want to tear this cover off. Once I get that on, I want it to be stayed on forever. I'm not going to tear the base off either. So I have to decide how I want the bulb to come out. And what I'm thinking is that if I made a hole there, 3 holes, large enough to reach in, that might be good. Let's see if I've got room for that. So my rough number is that 100 millimeters is how much you need to get your hand through and actually work. You know what? I have just enough room, I think. So let's offset this by the default and then change it to safe distance. And then I can make a tangent to that and to that and to that. Well, I want it to be the center one. And how big is it then? 107. Okay. So that's enough. Even if I do safe distance, come on. Safe distance times 1.5. I think I still have enough room to work in there. Yeah, it's still a little over 100. So let's make that for construction. And let's put a point and make it coincident with the origin. Select that point and do a circular pattern around the point. And I want 3. And I want that. And of course it's going to ignore that that point was there. Make it coincident with the origin. Okay. And cut that out. Alright, so now I can reach in through the bottom and do that bulb. But saying that, I run into another issue. I don't mind that it looks kind of funny looking in. Because who's going to be looking at it from the bottom? What I do mind is that I have 120 volts right there, and a big hole that you can stick your hand in through, which just adds another little layer of complexity to the design that we need to address. But it's not a huge problem. Just keep on working it. Keep on working it. So what can I do for that? Now that's 35 millimeter diameter. It's a little bit too tight to do curved wood. But looks like I'm going to have some big leftover chunks of this wood once I've cut. So maybe I can figure out some kind of thing that builds up around it. You know, stack things up. Protect it. Ooh, come to think of it though, that is not acceptable. Because I also cut off the hole. Suppress this real quick. I also cut that hole right out of existence, didn't I? I sure did. Alright, so maybe this idea isn't a good one. Not all your ideas are going to work the first time, and some of them you just throw away and try something else. So how do I get this light bulb in and out? Because I don't want anyone to be able to reach down here, at least not without opening the lamp up, or something like that. So that's a tricky question. If I have cutouts in here, maybe you could reach through, but I'm not sure about that. You know what? I am gonna take a few minutes to think about it, and then resume the recording after that. Okay, so just spun this around in my head for a little while, thinking of different ways to get in here. And it occurred to me that a lot of lamps, or a lot of lamp shades, are just open on the top. And people don't seem to mind that at all. So that's what I'm going to do. Still leaves an issue with the electrical, but I think I've got that solved as well. Let's offset this. Yep. And I'm gonna do equals safe distance times 3. So that's 12. Yeah, that's actually too little. Just make it 20. 20 is a nice round number. Tangent. And get rid of that. And so how big is the circle? 200. Very easy to get through. Also makes assembly a little bit easier, so that's a bonus. So now it's open on the top. Which means anyone can just reach in there and grab the 120 volts. And they'd have to almost try to, but even still, not ideal. So I need to do something about that. Hide these, just get them out of the way. And I'll do the same thing here. So what can I do about that? Well, I can stack up wood pieces that are designed to fit very nicely. And let's see. So first thing I'm going to have to do is I'm going to have to account for where that is at wood thickness, even though wood thickness changes. So I'm actually not going to start there, drawing there. I'm going to start drawing on this one. And make it perpendicular. And I'm going to make it equal to wood thickness. Okay. And actually I'm going to go plus 0.1. Just give myself a little bit of extra breathing room so it slides nice and easy. So then I can go down here and I can go make a circle that matches that. And then I can make a couple of lines to match that. Make this parallel and equal. And finished doing what I was doing over here first. Make these perpendicular. And get out of there, edit my new sketch, and make that coincident. Okay, and then just grab that, coincident. Okay, and then I can trim this out. So that's going to be a hole in the plate that I'm making right now, so that it fits real nice around this whole assembly right here. And what else does it need to have? Well, it needs to be able to go, these wires need to be able to come up and get to that socket. And I suppose they could go through a hole, but I think I'd rather just have this whole area be a hole. So, grab just these, convert them, and I'm going to go like that, make these parallel, and then make those parallel as well. And then I'm going to do another trim. There we go. So now I got that hole. Alright. So I can't just make a circle, because if I make a circle for the outside of this piece, it obviously hits these. But let's see. If I go tangent there, it's too small. So I want to go coincident there. Okay, so that's like my maximum diameter. Okay, and I want to offset this by, well, by safe distance. That's what it's there for. Okay, so obviously that's too big, because this is already going to be in place when I put it in the feed through. So this is also going to be for construction, because can't use it, but we are going to use it in a way. So I'm going to make a 3-point arc. That's just make it concentric there. That's the same thing as make it equal, but okay, SolidWorks, you're the boss. And then we need to kind of curve it in and then curve it back out. So I need to curve it in, have a curve on the inside, and curve it back out. And so I'm going to make that tangent. Make these tangent. I'm going to make these tangent. And then I'm going to make this tangent. Okay. Now the center of this should be centered with this. So it's not quite getting it. Midpoint. There we go. For construction, make it parallel here. Okay, that didn't work. Let's drag this manually And then just for the moment, let's fix it. What if we do that? Oh. Can I drag it? Yeah, it won't let me fix it. Okay, fine. I will make a temporary dimension, and that should make it happier, maybe? Okay, fine. Drag this back so it's almost straight, and then make this parallel, and then I can delete this dimension, and now that's all gravy. This we also want centered, so I'm going to go from there to the center, midpoint, and make that perpendicular for construction. That broke it again. Okay, fun. Okay, and if we, oh yeah, can't fix that. Gotta dimension it. Yeah, whatever. And will let me do it this way. It will. Okay. Go from here to here. Make that for construction as well, and make it perpendicular. Okay. We're doing good. Gonna offset this equals safe dist plus 5. And let's see how that turns out. A little bit. Actually, you know what? That's not how I want to do this anyway. So just delete this entirely. And let's convert these. And select the chain, make it for construction, and then offset it. Fine. And safe dist. And then just have to decide how I want this to work out. Let's try making these equal. These have to be equal. Well, I'm sure if that makes a difference. I think they're already equal. 7.448, 7.448. Yeah, my other dimensions are. This is making them equal anyway. So we go coincident there. And let's make these for construction. Okay. So then we can delete this. And let's see. We want, see, that looks good, but we can still do quite a bit of weirdness here. Yeah, no matter how I do that, though, it doesn't get onto this one, so that makes things a little bit easier. And let's see. What if we offset this by the safe distance times 1.5? Nope. How about just by safe distance? That's good. For construction, and then do a coincident with the center point. And that makes everything solid. So I want this. Nope. And that, I want to do a circular pattern of 3. And it automatically decided it wanted to be on the center. That's good. Okay, so I think got a winner there. Okay. Make it wood thick. And okay. And so yeah, the wires can run through there and up into there and blah 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 blah. So it looks like these are a little bit higher than wood thickness. I forget what I used to define how high those would be. Let me see real quick, roll back. Is it this? Yeah. I think it's just safe distance times 1.5. Okay, that's fair enough. Just discard that. And down to there. Wait, what is this circular pattern down here again? Was it something that I don't need? Yeah, we'll leave that for now. Okay, and what's the sketch? We don't need to see that. Alright, so as this comes up, we want it to match this. So we're going to have to make the next one out a little bit more. But first we have to, actually we do need this sketch still, because we're going to need a couple more of these just out and out. And parallel equal. And parallel. And coincident. Okay, and I don't know if we need all these, but might as well just draw them in real quick. Alright, so our second one, we're going to need the circle again. Well, no, we don't need the circle. Excuse me 1 second. Oh, sorry, scratchy throat. So the second one, we don't want this nut turning. It's in a tough place. So if we can, let's use this next block of wood to actually lock it in place. So make a coincident or collinear and a collinear and one more collinear, and that should be fully defined there. Grab it. Okay. And then we also need this. So let's see. Just going to put a point on there and do pierce. And do a point right here. And do another pierce. Make these parallel and equal. And then, let's see, do a coincident. And also want to be, let's see, perpendicular with that. Okay, let's trim. Let's not trim. Let's make those for construction and just draw in two little lines. Okay. And then we still need the wires to be able to come through. Come to think of it, this could have been closed up. And I think it might actually be better if it is closed up, because the next one it's going to have to be closed up too. So, no big deal. Go back, make a little modification. Those. Make these for construction. This. Fill it in. Oh, come on. Make these concentric. And then I just need two little lines right here. And right here. And hopefully that works. Okay. Let's do the same thing right here. We want convert entities, select this inner loop. Okay. And we might want it to be a little bit longer than that. And let's say from here to the midpoint, make this parallel, make these parallel, make these equal, make this a construction, and let's see, we want to mirror these, so we need to, let's see, it's the best way. Go like this, and go like that, make this perpendicular, make both of these for construction, and then I can select this, this, and this, tell it to mirror, but that's not how I want it to mirror, so we'll start mirror first, then select what we want, and tell it to mirror about that. Okay, so now I got just a slightly bigger hole so the wires can start curving in. We don't want them to curve in all the way yet because we want a little bit of material around here to keep the nut from spinning on us. And since these are above the wood thickness, or pretty much any wood thickness I'm going to have, I'm just going to convert this again. So we've got two that will be about the same size or same shape on the outside. So wood thick, and there we go. So then that should hold the nut in place. Now this is on the upper side of the wood thickness that I'm likely to have, so the next one's going to need a little bit of clearance for that too. But it doesn't need to hold the nut from turning though. This one's doing the job. In fact, the actual flats on the nut are fully inside of it. So let's make our next one. So this one is where it starts changing. This one I want the wires to be able to come all the way in. And you know what? Saying that, I want the wires to be able to come in a little more than it anyway. Let's make this slot, actually dimension it to be, say, 10. That way they can really start to curve in already. Okay, so this next one, we want it to be probably almost the whole radius or the whole diameter. Can we get there? Well, no one's going to be able to reach up and under, and even if they did, that's going to be a small thing that they could barely get to. Yeah, that can work, I think. So we got a round piece. Just thinking of how it will hold. And yeah, we don't need that. Let's go like that. So we've got a little ring. So everything inside the ring is going to be kept. But then we probably want something going in towards the center also, I think. Yeah. Let's make the ring for now. We can add more. Okay. And let's convert this whole face and then convert this as well. That way we've got these spaces in here. So we want those. Actually, I'm going to delete this again. I want to convert this, and I want to offset this face by 2 maybe? 2 works. Even 3 works maybe? Yeah, I think that works. Okay. Kind of eyeing it, you know, but extrude boss, we want this and this and this and this and this and this. And then we want to only go with this body here. Alright, so now the wires can come in there, and if we need to, if they're a little bit too long or whatever, you can kind of have a little bit of space to sit in there. Whoops. A little bit of space to sit in there. So how do we keep this rotating? Obviously, these pieces will be glued, but how do we keep it from rotating while we're gluing it, or to get it lined up just right? Well, we can, first of all, go ahead and hide some things, get them out of the way. And hide that too. Let's go sketch, sketch. Let's convert this and do just a tiny little cut, say 0.25 into that. So now, got that little cut out there, and what I'll do is when I laser cut that, I'll just do that bit as an engrave. That way, it will, ooh, we have to fix that. But yeah, this way, if it's engraved like that, then it'll just sit on there while I'm gluing it, and it should be easier to deal with. I need to deal with this first, right now. So, we've got this as our marker point, and we can just, let's see, come on. And let's see, we wanted this to be parallel and equal and coincident. For this we can just go coincident, and then another coincident with that, and just cut it out of this one. So yeah, we've got a piece chunked out of there. Yeah, that'll, you know, no one's gonna see it. That's good enough. Actually, that might help, you know, kind of rotate it in, lock it, get it just in the right spot. That's fine. Let's show everything again and get some things out of the way again. Okay. So, then the next layer, we can be a little bit more generous with as far as space, because we basically just need, at this point we've curved in the wires, and they just need to be that much space on the inside. So yeah, this one's easier. Okay, and then do that, and let's see how much distance we've got there between there and there. 1.27, so we've got a stack of 1, 2, 3, 4, 5. So yeah, it should be good. I'm going to do one more just to be 100%. That's not what I want. Mirror from that, and good. All right. So we got the stack of wood bits. So those all get dropped on there, kind of glued together. And these will all be glued together, but they won't be glued to the base plate. They'll be held onto the base plate when that gets screwed down. So, all right. That works. We'll get our ball back. We don't need this sketch anymore. All right. So now what we've got. So we've got that. We still need to do we still have this suppressed, the circular pattern of the sides, but we need to figure out what we're going to do with the sides, because right now I can get out the top, but not out of the sides anyway. So my first initial thought when I started this was that I'd have cutouts, roughly rectangular rounded edges, and then put some like black translucent acrylic in there, so it looks black when the light's off, and when it turns on it looks kind of a little bit yellowy, but that's why I'm thinking that's not what I want, because it's kind of a dull, gross yellow. It looks really neat if you've got like a colored LED behind it, like a blue shines through almost perfectly blue, and it's almost like magic because it's just a black surface and then it's a blue LED behind it when it's on. But this is just going to be like a clear white light, and I don't want it getting tinged by the color of the translucent acrylic. Then there's clear acrylic, of course, but then you're going to be looking basically directly at a light bulb, and that's going to be too bright. So what I'm thinking is do a whole bunch of cutouts, either in a pattern or in some kind of geometric design. So, see, this is that body. It's going to hide everything else. Oh, and we'll save again. So, if I do horizontal, it allows light to get out, but you only be looking straight at the light bulb if you're looking like at eye level with the lamp. If you're like above the lamp or below the lamp, you won't be looking directly at the bulb itself, so it won't be as intense. If I did them vertically, you'd be able to see the bulb. So I want to do them horizontally. And of course I want them to be rounded. Do like that. Another option is that I could do something like that, like a series of those. Or even like series of those. But I'm not 100% on those. Again, it gets closer to vertical. Still probably not a huge concern. But I think this will work. So we go tangent, and I'm going to go collinear. Then I'm going to do, for construction, I'm going to do another slot inside of this. And the one inside is the one that I want. And let's see. If looking down at 40, just doing a little bit of mental math. I don't want them to be too big because, again, you'll be able to see the light bulb directly. Don't want them to be too small. I think 3 is a good in between. And how much space do I want between them? It's a good question. But I do know that for this, I want it to be safe dist, because that's what safe dist is all about. And Oh, get out of that. Select chain, and then I want to do a linear pattern following this direction, but the other way. And say 50, maybe 40, I don't know. Well, I can adjust it later. I want how much space. I think just making it equal might be ideal, or thereabout. I'll have to adjust it a little bit, but just to get an idea of what I'm dealing with. 40, 38. Let's see. 40 divided by 9 is 4. 4 times 9 is 36. Okay. I like 9s, or at least I like when everything matches up, and so far everything about this is 9s, so it's going to be a multiple of 9. Why not, right? So I'm going to go collinear. I'm going to do for construction for the whole thing. And then I'm just going to make it equal to this one up here. And it's fully defined. Okay, so I've got slots all the way across. And having done that, I realize I may have removed too much, and it might be a little bit boring. Both of which are problems. So what I'm going to do is get out of here, make a new sketch on top of it, because I don't want to mess with the basic geometry, and the pattern and all that are good. It's just I want to make some slight adjustments to how the pattern is laid out. It's 39, which is an odd number, so I can do some interesting things with that. Okay, so then if I go here, I'm just going to make these kind of an alternating pattern. Okay. So let's go pretty much to the center. Just drawing a line here and make that equal to safe dist and for construction. And then I have another one there and another one here, and make these collinear and equal, and collinear, and then there to there, and there to there. Make all these for construction and equal to that. Okay, and let's see how this looks. Come on. Yeah, you're just gonna give me trouble, aren't you? Well, yeah, it would. No, it's gonna be too long. So what if I go from the center to the center? Different types of center, but they're still centers. Oh, come on now. Come on, let me move. And this I can adjust its length, right? Come on. Midpoint. Okay. Okay. Can I do a perpendicular now, please? Okay. For construction again. And then I just need the equal length again. And that's fully defined. Good deal. Alright, so I'm going to select all 5 of these chains. And let's see, 39. What? Oh shoot, it's 36, not 39. Oh well, it's still okay. So half that's 18. And direction 2, just for this, now let's set it to 20 so it's easier to dimension or to make it coincident. Okay. So now we got a nice little pattern there instead of just straight slots the whole way across, and it's also a little bit stronger that way. And that's a whole bunch of cuts to be doing all at once. I suppose it might take a little bit longer to do this with a laser than to do it right here. That's a lot of little cuts it's got to make. I think it'll look really nice, so it's worth it, probably. All right, and let's show everything again. And then let's do our circular pattern. Okay. So, if you imagine the light being on, let's see. You're looking at it like that, you can still see the light bulb, but if you tilt up, let's see, you need to tilt up quite a bit before you don't see the light bulb. At that point, you're almost seeing the light bulb there. Might need to adjust that still. Let's see. So, this is safe distance, right? Yes. And we probably want safe distance between between the openings too, in theory. But 3 is too big, apparently. Maybe a 2.5. Let's see how 2.5 looks once it's all. Let's see. Still quite a bit. You still have to be tilted way up before the light bulb is not seen directly on. Let's try 2. So that's 2 for over 4 millimeters. So yeah, that right about there. It's not too high, I don't think. So yeah, I'm happy with that. And then we need to see how the spacing works. How much space do we have between them at this point? We have 4 between them at this point, which is more than safe distance. See, you can always undo the changes to the sketch if this doesn't look right. Uh, 39? Yeah, I'm going to make it 39. Why not? It's not a multiple of 9, but it's a multiple of 3, which is, that's good. So we need to get rid of you. And so then we need to make this, and it's for construction, and it's equal to that. And then let's make it coincident there. Okay, that works. Then we need to modify this a little bit too. So where's our number? 14. Okay. Let's show this again so I get something to work with. And then I need to do one more pattern with this and this. Direction, the other way, good. And then I'll do a coincident down here, just for the last of the 39. That works, fully defined. And alright, so even more cuts, hooray! But, like I say, make it look a little bit nicer. Alright, I like the look of that. So we got a nice legs, got a power cord coming in through the bottom, got things around there to protect it. Yeah, I'm pretty happy with that. Alright, so I'm going to save this. Alright, and then I need to start taking care of the kerf. So I guess I'll just start with the first piece here I see in the top. So these are always going to be 9. We decided that, so that makes that easy. Do convert all the insides and just select all of them, and we do an offset. And I can't put an equation in there, so I'm just going to do an offset of 0.1, and then I'm going to reverse offset. I want to offset inwards. Okay. And then I can put in the equation, which is going to be wood kerf divided by 2. Okay. And then I'm going to do an extruded boss. Lots of lines for it to process all at once. Go up to this surface. Come on, you can do it. Alright, and I only want it to be on that piece. I'm wondering if I should have fillet these edges. And down there as well. Let's see how it looks. Let's see. And say 20, 30, 40, 30. Yeah, it works. Do I like that more than the hard edges? I do like that more than the hard edges, so I'm going to do that on the bottom as well. 1, 2, 3. 1, 2, 3. And there. Okay. I want to put these two before that kerf offset. Which will take a second because that Kerf offset was huge. Okay, so everything up to here, I'm going to put in a folder real quick. Call it model. And save it as it is. And I'm going to do another sketch up here. I'm going to convert. I'm going to offset and fine. So I'm going to do kerf equals wood kerf divided by 2. And up to surface. And there. Okay. So that piece is fully curved. This one doesn't have to be. This one doesn't have to be. And let's do this one. And so what I just did before, that method with 2, that's how I would do it if I'm engraving stuff on it. I don't actually need to do that, so I'm going to do it a little bit differently on this one, just to show you both ways. If I don't have any engraves to worry about, I'm still going to offset, but first I did the convert all inners. Then I selected them and made them construction, and offset them reversed again. So this time I only have the offset as actual lines. Everything else is construction lines. And somewhere I've got the number. There we go. Okay. And then I'm going to offset this one as well. So now I can just do it as a single, and it's just basically going to make a whole new panel. But I'm going to just tell it to merge with the old one, and it'll just kind of overwrite it basically, bury it, whatever, however you want to say. And slowly, slowly, slowly. So, yeah, at this point, I think we get the idea. Basically, just going to repeat this for all the panels. I'm only going to do one of these because all 9 of these are the same. So I'm just going to do one of these, and then I can just cut that same panel 9 times. Only going to do one of these, cut that same thing 3 times. So I'm going to stop recording at this point because, yeah, basically it's pretty boring from here. It's just the same thing I just did. Only other thing I will say about that is once I do all these curves offsets, I'm going to put all of them into a single folder called kerf, and then I'm going to lay them all out flat, put all those features into a folder called flat, and then I can measure the thickness of my wood, enter it in here. Come think of it, I don't need those anymore. And yeah, then I can just regen from that, do a Control Q to regen, and I'll be able to export a DXF and laser cut this lamp, which I actually probably will not be doing immediately because I haven't decided what color I want it to be yet, so I don't even have the wood painted. But that's kind of beside the point. If you're here for the SolidWorks stuff, pretty much covered the actual design stuff and kind of a little bit of design philosophy, a little bit of just source parts or parts that were purchased that you don't even have a diagram for. Just so yeah. Any questions, please post them below. If you feel like subscribing, do so. If not, don't. If you like, don't like, whatever. Do all the YouTube stuff. You know the deal. All right. That's it.